finding measures involving diagonals of a rectangle. So in the rectangle below, KM, so this whole, I gotta click on my pen. So this whole diagonal here, ooh, I don't like that. Let's clear that and make that a little smaller here. I don't know why my pen all of a sudden got a little too big there. All right, KM, this whole thing is, and I'm just gonna write off to the side here, is x minus 2, and then I'll change my color for the next one. JN, which is just this piece here, is 23. And let's go with pink for the next one here. KNL. So, and I'm gonna just kind of do a pink thing here. So KNL, so I didn't do the whole thing, so I'm not covering up all the green. This is 124 degrees. All right, so we have some information here, but we need to remember some of the properties of a rectangle before we move forward. So again, if you're not taking notes, you should be taking notes. You need to be writing these down, especially once we get to the geometry portion of this. There is a lot of postulates and theorems, or they like to call them properties on here, but same kind of idea. So there's a lot of pieces to remember once we get to geometry. We definitely need to be writing them down and keeping notes so that you can go back to them and say, oh, well, here's my rectangle page. I'm just going to add to that. Or maybe you already have everything written down for rectangles, which is great. Then you can just go back to that page and reference it. So first, a rectangle is a parallelogram with 4 right angles. So parallelogram, if you didn't remember what that meant, you can click on it, and this will actually open up and tell you what a parallelogram is. So it's in the word parallelogram. So parallel means that it has 2 pairs of parallel sides. So pair meaning left and right, that's one pair, those are parallel, and then top and bottom, that's another pair, those are parallel. So 2 pairs of parallel sides makes it a parallelogram. A rectangle specifically has 4 right angles. So that means that all of these angles are right. And we put a little square in there. That's a symbol for showing the right angle, meaning a 90-degree angle. Because it's a rectangle, we already know all 4 corners are going to be right angles here. And I know I put that in pink again, but and because a rectangle is a parallelogram, its diagonals bisect each other. So that's one of those rules of parallelograms that we went over, I believe it was last week, for the videos that we went over. So one of the properties of a parallelogram is that the diagonals bisect each other. Bisect means to cut in half. So if I draw both diagonals here, JL and KM, this is the midpoint, this point in the middle for each line. So it means that it cuts JL in 2 equal pieces. JN would be equal to LN, and then it does the same thing for the other diagonal. So MN would be equal to KM. It cuts them in half. It doesn't always mean that it cuts them equally, but actually for a diagonal, it does of a rectangle, because the diagonals of a rectangle are congruent. So specifically a rectangle, and this also works for a square, the diagonals are congruent. So if it cuts this in half, then all the halves are the exact same, because if JL is the same as KM, meaning that's what congruent means, and I cut them in half, well, I cut the exact same length in half. So if JN is 23, then KN has to be 23, LN has to be 23, and MN has to be 23. So this is very important. We need to remember these qualities so that when we move forward, we know what to do with them. And we know how to move forward in our, and I'm just going to click clear here, and it's going to clear out all my other stuff here. So I'm going to keep scrolling down here because they do have it marked also. So they said, we're given that KM equals 8x minus 2 and JN equals 23. Remember, we just said the diagonals are congruent. So we know that if this half is 23, then this half down here is 23, and L. So 23 plus 23 is 46, and they get 46 right here because they just did 23 times 2, which is the same thing as 23 plus 23. And we know if JL is 46, KM is also 46. Remember, the diagonals are congruent. So we can set 8x minus 2, which is what they told us KM is, equal to 46. We know this expression has to equal 46 in order to make this a rectangle. So then we just go through and we solve it. They add 2 to both sides, and then they divide by 8, and they get 6. So they already know what x is. And they're asking us to find x and NJM. So they want NJM, this angle up here. So let's scroll down just a little bit here. So it says, by the vertical angle property. So they're actually throwing a couple other things at us that we've gone over in the past few weeks. So vertical angle property means that they told us this side was 124. Well, I can go across the vertex here, so both angles have to be 124. So that's why they have it marked 124. So I'm going to clear really quick. So we know that this is 124. We also know that these are congruent. They have these marked. Because remember, the whole diagonal is congruent, which means that the halves are congruent. If I divide a number in half, and it's the same number for both, well, then I end up with the same half for each. So the diagonals are congruent and bisect each other. So that's how they get mn is equal to jn, which we just talked about. And so that means that JNM is isosceles. Here's another one that we went over a few weeks, or in the last couple weeks. So the base angles are congruent. So if you have an isosceles, which means at least two sides are congruent, I can go opposite angles here, like this. So, and this is a little crisscrossy. I wonder if I can make that a little smaller. So I'm going to go across from this side, and I go to that angle. I can go across from this side, and I go to that angle. So I go from the side and the angle across from it, and they will be congruent to each other. We also have the triangle angle sum property, which is another one we've gone over in the last few weeks. So we do have a lot of notes on this one. If we haven't been writing notes, we have a lot to write down on this one so that we can remember what to do. The sum of these bases must be 180, right? So we have 180 because the triangle equals 180. That's the triangle angle sum property. I'm going to subtract 124 because I'm already using 124 in the triangle, and I'm left with 56. So when they say the sum of the base angles must be 56, sum means when we add these two angles together, we should get 56. And there's two of them, and they're the exact same. Remember, we already said they're congruent. So we divide by 2, and we get 28. So we end up with both of them being 28, which we only want one of them. But we do have to remember quite a few properties of geometry for this one topic. All right, so let's go ahead and click here, and next. Let's go ahead and try this out. Okay, so in the rectangle below, FH, which is this whole thing here, equals 4x minus 2. Let's switch over to green here. EG, so this whole portion here, EG, equals 5x minus 10. So we have both diagonals. What do we know about the diagonals? They're congruent. So I know 5x minus 10, and let's see, I'm going to put equals in black here for whatever reason. I'm going to go back to pink. It's not going to be quite the same pink, but close enough. Oh, it looks pretty close. All right, so I know 5x minus 10, this diagonal, is going to equal 4x minus 2, this diagonal. So I can set the diagonals equal to each other, which I do need to set them equal to each other so that I can figure out what does x equal. That won't be the end of that one, and I'll explain in a moment. So we have this one set up, and we'll go through and we'll solve this one in a moment. But as soon as I have diagonal information, I can start setting up this equation. We also know that IEH, so IEH, so this angle up here, I'm going to put this in red. So this angle up here equals 34 degrees, like this. So this is all of our given information. So first, let's go back to this equation here, and I'm just going to write the rest of this in black here, just so that I'm not mixing up the colors. So we want to bring our variables together. Oh, let's cover what we're finding first, because I read that in my head, but I haven't read it out loud. So I want to know, what is this length here, EI? That's the first thing they're asking. So in order to know EI, I first need to know either what is the whole thing or what is a half. But in order to find that, I'm going to need to know what is x. Once I know what x is, when I solve this equation down here, I can go back and plug it into either one of these. So I'll know what the diagonals equal. And then I can divide by 2, because remember, this is a midpoint for everything. So if I know a diagonal, I can just divide by 2, and that'll tell me what half of it is. So let's go through and solve this. So we have negative 4x minus 4x, sorry, not negative, minus. 5x minus 4x, that just gets us x because 5 minus 4 is just 1. I'm going to bring down my negative 10 and my equal sign. Don't forget to bring things down. I still have quite a few students in IM1 and IM2 that forget to bring things down. Don't forget to bring it down and keep it in an equation. It makes it much neater. You won't forget things that way. All right, 4x minus 4x, cross them out, and bring down negative 2 here. These cross out specifically because one's positive, one's negative. It's the exact same number. 4x minus 4x is, in fact, 0. All right, our last step to find x, we just have to add 10 to both sides. And x comes down. Negative 10 plus 10, even though it's upside down, one's positive, one's negative, and they're the same number, so they become 0. And negative 10 plus, or sorry, negative 2 plus 10, we subtract, and the bigger number decides my sign. So 10 is bigger, it's a positive 8. So now I know what x is. I'm not done yet. They didn't say what is x. They want to know what IE is. So now I'm going to go back over here, and I'm going to look at 5x minus 10. I'm going to plug in my x. So instead of x, I'm going to put 8. And I get 5 times 8 is 40 minus 10. 40 minus 10 is 30. So now I know that this green diagonal equals 30. That's the whole thing. Do they want the whole thing? No. They only want half of it. So I'm going to divide by 2 and get 15. So yes, this one did require quite a few steps just to get to this first one. And we have to remember quite a few qualities of a parallelogram and a rectangle to get there. I have to remember that the diagonals are equal. Then I have to go through and solve an equation for that, plug it back in, and then I also have to remember the diagonals bisect each other, meaning cut each other in half. So I have to divide by 2 once I get my answer. All right, so let's do this last portion here. So we want to know FIG. So we want to know this one here. So we're going to go back to using Isosceles Triangle. So remember, I know that this side is congruent to this side. I already know that because the diagonals are congruent. They get cut in half. So the halves have to also be congruent. Half of the same number is the same number. So if this one up here is 15, then this one down here is 15. So if I know that they're congruent, that makes it an isosceles triangle. So opposite angles, or the base angles, have to be congruent. That makes this one 34. I need to fill that one in so that I can use the triangle angle sum theorem. That means that all angles of a triangle add up to 180. And then I'm going to subtract what I'm using. I'm using 34 at the top here. I'm using 34 at the bottom here. So if I add those together, I get 8 and 6, because 34 plus 34 is 68. I'm using 68 degrees of the 180 already. So I'm going to go through and I'm going to subtract. Here's me borrowing. So I end up with 112. So this angle here, I'm putting a dot there so you know what I'm talking about. That angle right there, so this one here, is 112. And I can go across the vertex. This is vertical angle. This is another one of those ones that we mentioned on the explanation page. So vertical angle means I can go straight across, and those two angles have to be the same. So if this side's 112, this side is also 112. So I have 112. And I'm going to click check. Yay! All right, we have 2 more of these. So let's go ahead and go next. All right. So in the rectangle below, RV, so we have RV, and I'm going to try to write it in here because I have a little more room. So 3x plus 6, TV, I'm going to put this down here. So TV equals 6x plus 9. And I'm sorry if that's super bright green. I meant to make that a little darker. And then VUR, which we'll do in dark blue here. So VUR, so this angle here, I just followed the letters VUR, and the angle that you're looking for is actually always in the middle here. So that should be your vertex. So we have 49 degrees. All right, So now we want to find, I'm going to go over here. We want to find SV. SV is this one here. So we're not given anything for this diagonal here, but we are given information for the diagonal, both the pieces of the diagonal for the other one. Remember, the diagonals of a rectangle are congruent. If I find this diagonal, I already know what the other one is because they have to be the same. So if we go back really quick, let's go red. So we're given this half is 3x plus 6, and this half is 6x plus 9. Remember, they're halves, and I'm saying half. So I already know that 3x plus 6 has to equal, let's do that a little darker green so it's a little easier, has to equal 6x plus 9. So I know it's not the same color green, but I just wanted to be a little darker on that one. So we know these two halves have to equal each other because, again, half means equal pieces. I cut them in half. So let's go ahead and solve for x. The reason we have to solve for x is we need to know what x is so we can go back and plug it in so we know what one of these halves are. So we need to know what x is so that we can figure out what the diagonal is. All right, 3x minus 3x cancels. 6 and equals come down. 6 minus 3 gives us 3. Don't forget to include the x with that. Again, quite a few students who will go 6 minus 3 and just write the 3 and forget that the x is there. Well, then you get 6 equals 3 plus 9. You do 3 plus 9, you get 12, and you go 6 doesn't equal 12. What happened? Don't forget the x because that's important once you get going here. So we're going to subtract 9 from both sides because we're trying to get this x by itself. So 6 minus 9, I subtract. My bigger number decides my sign. So 9 is bigger, negative 3. 3x comes down along with the equal sign. 9 minus 9 cancels. All right, last step here is we just need to divide by 3 so that we can cancel this one. Technically, this one would also cancel, but remember, by canceling when you're dividing, it means 1. So negative 3 divided by 3 is negative 1, and then equals 3 divided by 3 is 1, not 0. When this one cancels, it's 0 because it's plus and minus. We're saying 9 plus negative 9. So that's why it cancels to 0. But this is 3 divided by 3, so it becomes 1. We don't have to write 1x, just x. All right, now we want to take this x and we want to plug it in. Doesn't matter which half we plug it into. They both have to equal the same thing. So instead of, I'm going to just go ahead and do 3x plus 6. So instead of x, I'm going to put negative 1 plus 6. 3 times 1 is negative 3 plus 6. Negative 3 plus 6 is 3. Because remember, they're opposites. So that means I subtract my bigger number, which is 6, decides my sign. It's a positive 6, so it's a positive 3. So I know that RV has to equal 3, which also means VT has to equal 3. And you could plug it in here, because if you plugged this in, so I'm plugging negative 1 into this x, if I plugged it in and I got something different than 3, which I do get 3 again, but if I get a different answer, then I did something wrong in my first equation. So this is actually a good check to check that both of them, in fact, get you 3. So I know if these halves equal 3, what do these halves equal? Well, they also equal 3. Because remember, the diagonals are congruent. I'm cutting them in half right here. So if I know RT is the same thing as SU, and I cut it in half, I'm cutting it in half, the same number. So I know if this is 3, then this is 3, then this is 3, then this is 3. All right, so that was a lot of thises, but I'm hoping my pen followed pretty well on that one. All right, so let's do the last piece here. So we want VRS. So we want this angle up here. Let's see. So we need to do a couple of things here. So first, we know that these angles are congruent. Or not angles, sorry, sides. We just talked about that. And if these sides are congruent, then we call it an isosceles triangle. And we can go opposite sides here, and they equal the same thing. So I know this one's also 49 degrees. So far, all we've done is filled in this side. Well, I want this other side here. What does all the corners of a rectangle have to be? 90. So I know that this corner has to equal 90 degrees. I'm already using 49. So I could have done this in a different way too, but this is kind of the fastest way to do this. So if we remember the 90, then we can just subtract. Here's me borrowing again. I get 1 and I get 4. So this has to be 41 degrees in order for these to add together to get 90. All right. So let's go with 41 and check. Uh-oh, which one did I do wrong? Let's see. Did I do my subtraction wrong on this one? $49. I'm pretty sure that's right. Let's see. I get 10. No, so that should be good. And it all moved up too, so that messes up my figure here. SV. Oh, SV is wrong. Okay, so I did something on SV that they did not like. Let's see. All right, I'm going to rewrite my equation over here real quick. So we end up with 3x plus 6 equals 6x minus 9. Sorry, that dot shouldn't be there. So let's see, what did we do? We subtracted, and we get 6 equals 3x minus 9. Oh, that's what I did. I had a plus right here. Uh-oh. So I want to add 9 to both sides, and I end up with 15 equals 3x. When I divide by 3, I get 5 equals x. Ooh, I wrote the equation wrong, didn't I? So is it bad to get one wrong? No. But sometimes you accidentally write it in incorrectly because I wrote it on the diagram incorrectly, and then I kept referencing that incorrect one instead of looking back up and making sure I wrote it down wrong. It does happen. Just go back and try it again. And this one is nice enough to tell you, and I know there's a whole bunch of writing up here. So I'm going to remember that my x is now 5, but this tells me right here I got SV wrong. It doesn't always do that for you, but it does that quite a bit. So now I'm going to go back and I'll use this equation again. So I have 3. Remember, x was 5. We just wrote that down. Plus 6. So I have 15 plus 6, and I get 21. So that's a much bigger number than I got the first time. So that means RV equals 21. Remember, if RV equals 21, they all equal 21. So let's check it and see if I get it right. That was just an oops mistake, but it does happen, and it's okay. Don't get upset if you get one wrong. We're still learning, and that was just an honest mistake. I wrote it on the diagram incorrectly. So that's another thing you want to make sure. Go back and look and make sure that you're writing it down correctly before you move forward, because otherwise we do all that work and we have to go back and do it again. So it is a little frustrating, I know that, but we just have to slow down and make sure we're doing it right. And so let's see. I have 4x plus 6. Sorry, jumped right into this one. So Jn, they gave me 4x plus 6. And then Kn, whoop, this one here, they're giving me 6x minus 8. And these two they're not the same diagonal, but remember, it's a rectangle. Diagonals are congruent. This is a midpoint, meaning that it cuts all of them in half. Since they're congruent, it cuts them in half the same. I know those will be equal. That's going to be my equation right there. So I'll write that down below in just a little bit. And I kind of wrote it up here specifically so I could put the equal sign between them. All right, so let's go ahead and grab NK and JK. So this one over here is the one we want, and that's 39 degrees. So that's what they give us. So first they want to know, what is the value of x? So in this one, it's actually a little nicer. We can take that equation that I wrote up top there, and I'm just going to rewrite down here so I have room to put stuff in. And I'm going to confirm it's 4x plus 6, 6x minus 8. So I'm confirming, which I should have done in the last one. So when we're done with this one, we don't have to plug it back in. They're actually looking for x on this one. So 4x minus 4x cancels. Bring down the 6 and the equal sign. 6 minus 4 is 2. And don't forget to bring the x with it, and negative 8. I'm going to add 8 to both sides. And I get 14 equals 2x, negative 8 plus 8, those cancel. I'm going to divide by 2. Sorry, I'm running out of room here. So 14 divided by 2 is 7, equals 2 divided by 2 is 1, and I just bring my x down. So in this case, I don't have to go any farther. They want to know x. I don't have to plug it back in to find anything else. So that's kind of a nice change on that one. We don't have to plug it back in on this one. So now they want n, m, j. They want to know this angle down here. So in order to know this angle down here, remember we always have isosceles triangles when it comes to rectangles or squares, and these opposite angles or the base angles are congruent. So if I can figure out what this one is up here, this angle here that I'm kind of coloring in black, if I know what this angle is, then I will know what this angle is. So they gave us this 39 here. If we think about a rectangle, what do the corners have to equal? 90. So I'm just going to subtract what I'm using. And I get, let's see, 1 and 5. So I get 51. If this area here is 51, this angle down here that we're looking for is also 51. All right, let's check it. We should get our points. Yay! All right, one more. As long as I don't make silly mistakes here. Okay, so jumping straight into this one, we have AE. Whoops, gotta hit my pen. AE, and that equals 4x plus 6. BE, so they're kind of doing the same thing they did on the last one, aren't they? BE, so they're giving us these two halves, and that equals 5x plus 3. And remember, even though they're halves of different diagonals, we know the diagonals are congruent. They bisect each other, so all the halves are equal. So here's our first equation we're going to work out when we start working. They want AC, so they want the whole thing. So we are going to have to find x, plug it back in. That'll give us one of them, and then we'll know we'll have to add or multiply by 2 to get the whole thing. So we have a couple extra steps on this one. All right, the last thing they want here, let's go to green. I got a little darker. So green is BEC, so they're giving us this angle here is 122 degrees. All right, so let's go to this first equation, and I'm going to rewrite it here. Equals 5x plus 3. All right, so we need to work this out. Bring our variables together. So I have 4x minus 4x. Bring down the 6. Bring down the equals. 5 minus 4 is 1, so just x plus 3. My last step to find x, I just have to subtract 3 from both sides. So 6 minus 3 is 3, and that equals x. 3 minus 3 cancels. So I know x, but they're not asking me for x. So I need to go back, pick one, doesn't matter which one, and plug it in. So instead of x, I'm going to write 3 plus 6. So I have 12. And I'm just confirming really quick. Yeah, okay. I did write everything down correctly in the first place. So I have 12 plus 6, and I get 18. Remember, this is only half of it. This is the 18 I just found. I want the whole thing. And I use the word half again because this is the midpoint. It's halfway. So if this half is 18, this half is 18. I just want 18 plus 18, or 18 times 2, which gets me 36. So AC will be 36. And if they asked me for BD, it'd be the same thing. That's also 36 degrees. Okay, so now I'm going to go EDA. So I want EDA. I want this angle right here. So we have to do a couple things. First, we have to remember they gave us this one angle. So we're going to have to use that angle because that's the only one they gave us. So we know vertical angles here. If this side is 122, this angle here is 122. We also know we have an isosceles triangle every time we're dealing with a rectangular square. So these two angles, sorry, that was a really horrible arrow, but that was supposed to go over here toward the angle A. These two angles equal the same thing. And now we have to remember triangle angle sum theorem. What do they all add up to? 180 degrees. I'm going to subtract what I'm using. I'm already using the 122. So I have 8 and 5. So I have 58 left over when I subtract. Remember that 58 is left over for both angles. and both angles equal the same thing. So I simply divide by 2, and I get, let's see, 29 degrees. So I'm going to type in 29, and we should be good to go as long as I didn't make any silly mistakes on this one. Yay! All right, we finished another one.